Okay, on number 26, we have 100 males. 18 have admitted to being late to work at least once in the past 6 months. Another sample of 100 females, 14. So is the population proportion higher for males than for females? I'll skip down since I just read that question on B, the research and the null hypothesis. The null will be that PA is equal to PB, or I think I might have, when I wrote this, done PM is equal to PF for male and female, and then the alternative research will be that PM greater than PF. The sample size, remember, this is back to part A here, are the sample sizes large enough? That will depend on whether or not all of the numbers of yeses and nos are greater than 10. So for males, we have 18 yes and 82 no's. That's just 100 minus 18. And for females, 14 yeses and 100 minus that, or 86 no's. All of those are greater than, I put 5 here, but I should have said 10. I'll try and stay consistent with the other stuff I've. At either rate, they're large enough. Some books say 5, some 10, and we're going with 10 for right now. In fact, I think most books are going with that now, most newer books. And then there are the hypotheses from Part B. And then to get the p-value and stuff for their sampling distribution, it says show your work in here. I thought I'd already taken that out. But you don't have to show your work on these. For the 2-sample test this semester, I've omitted the calculation of standard errors for the 2-sample test to get away from maybe just being a lot of number crunching kind of thing. At any rate, now I'm going to pull my calculator over and go to the 2-proportion z-test, and I'm going to have 18 out of 100 and 14 out of 100, and it was greater than here, and calculate. And before I do that, let me, while I'm thinking of it, remind ourselves that when we get to doing that sampling distribution, it will have been convenient for us to have rewritten that as PM minus PF equal to 0, since that's the number we're going to need there. Calculate. You can see that the p-value is 0.22. And so there we have it. The center of the distribution is 0. The difference that we found in our data was 0.04. That's just the 0.18 minus the 0.14. The x-axis is labeled with the statistic, the difference between the two sample proportions, p hat m minus p hat f, and then the shaded area beyond the 0.04 is the p-value, which is 0.22. Should we reject HO? No, we reject if the p-value is less than 0.05. It's not, it's 0.22. So we fail to reject HO. We do not reject HO. And our if-then statement will be if HO is true, which we could state as P male equal P female, or we could have said if PM minus PF is equal to 0, those are the same thing. If the null hypothesis is true, then there is a p-value chance, a 0.22 chance of getting the statistic that we observed, or one more extreme, in the direction of our alternative hypothesis. So our statistic is the 0.04, and our HA was in the upward direction, so we go from our statistic up. So the chance of getting a difference between proportions, subtracting in the direction male minus female, greater than or equal to 0.04.